Hey guys, in this video we will be going over how to simplify expressions that contain square roots. So let's begin with finding the products of square roots. If we have the square root of 4 times the square root of 9, we can find this product by taking the square root of each factor, which becomes 2 times 3, and this equals 6. Also notice that if we instead multiplied the radicands first, and then take the square root, we also get 6. This will lead us to the product rule for multiplying expressions containing square roots. So if the square root of a and the square root of b are real numbers, then the square root of a times the square root of b is just equal to the square root of a times b, where the product of two square roots equals the square root of the product, and this can be used in either direction. This rule is going to be useful for simplifying square root radicals. So a square root is simplified when the radicand contains no perfect square factors other than 1. So as a side note, some perfect square factors are the following. So if we have a radical like square root of 45, we would not consider this simplified because the radicand, 45, contains a perfect square factor of 9, and the square root of 20 is also not simplified because 20 also contains a perfect square factor of 4. So to simplify the square root of 45, we factor the radicand so that one of its factors is a perfect square, so 9 times 5. And then using the product rule for square roots, we can write it as the square root of 9 times the square root of 5. And we simplify square root of 9 as 3. And for the square root of 5, since the radicand has no perfect square factors other than 1, this radical is already simplified. Therefore, square root of 45 simplifies to 3 times square root of 5, or simply 3 square root of 5. And we simplify square root of 20 in the same manner, where we rewrite 20 as 4 times 5, so that one of its factors is a perfect square. And then using the product rule, this is the same as square root of 4 times the square root of 5, which then simplifies to 2 times the square root of 5, or simply 2 square root 5. So as a side note, a radical in simplest form does not mean a decimal approximation. The simplest form of a radical is an exact form and may still contain a radical. So for example, the square root of 45 simplified to 3 square root 5, which is in exact form, whereas taking the square root of 45 on a calculator would give a decimal approximation, which is not considered simplest form. So let's write down some conditions for when a square root is simplified. So an expression containing a square root is simplified when all of the following conditions are met. So the first condition is that the radicand does not contain any factors other than 1 that are perfect squares. The second condition is that the radicand does not contain any fractions. And the third condition is that there are no radicals in the denominator of the fraction. So let's try a few examples and simplify some square root radicals. So to simplify square root of 54, notice that the radicand contains a perfect square factor of 9. Therefore, we can write this as the square root of 9 times 6. And using the product rule for square roots, this becomes square root of 9 times the square root of 6. And then this simplifies to 3 times the square root of 6. And since 6 has no perfect square radicals other than 1, we are done simplifying. Therefore, the square root of 54 simplifies to 3 times square root of 6, or simply 3 square root 6. For the next example, 12 contains a perfect square factor of 4, so we can rewrite this as the square root of 4 times 3. And using the product rule, this becomes square root of 4 times the square root of 3, which simplifies to 2 times square root 3, or simply 2 square root 3. And to simplify the square root of 200, notice that the radicand contains a perfect square factor of 100. Therefore, we can rewrite this as the square root of 100 times 2. And using the product rule, this becomes square root of 100 times the square root of 2, which simplifies to 10 times square root 2, or simply 10 square root 2. And for the last example, it looks like 35 has no perfect square factors other than 1. Therefore, this radical is already simplified. So what happens if we don't use the largest perfect square? For example C, for the square root of 200, this simplified to 10 square root 2. What if instead we used 4 as the perfect square factor and rewrite this as the square root of 4 times 50? This will give us 2 square root 50. However, we will need to repeat the process of simplifying this radical since 50 contains a perfect square factor of 25. So we rewrite 50 as 25 times 2, and then this simplifies to 5 times square root of 2. Multiplying 2 and 5 will give us 10 square root 2, which is the same answer we got previously. So although using the largest perfect square will save us some time, this will also give us the same answer no matter what perfect square factor is used. Let's try simplifying the next example. So 3 square root 8 is the same thing as 3 times square root 8. So we can simplify the square root of 8 since the radicand contains a perfect square factor of 4. We can rewrite this as 3 times square root of 4 times 2. And then using our product rule, this will simplify to 3 times 2 times square root 2. Multiply the 3 and 2, and we get 6 times square root 2, or simply 6 square root 2. And now our expression is simplified. Okay, now let's examine a quotient of square roots. So consider the square root of 16 over the square root of 4. The square root of 16 is 4, and the square root of 4 is 2, and we get 4 over 2. This fraction reduces to 2. And notice that we can get the same result if instead we took the quotient of the radicand first, and then the square root. We would also get 2. This leads us to the quotient rule for square roots. So if we have the square root of a and the square root of b are real numbers, then the square root of a over b is equal to the square root of a over the square root of b, where b is not equal to 0. Again, this rule can be used in either direction, and this suggests that the square root of a quotient is the same as the quotient of square roots. So let's try applying the quotient rule on a few examples. So for this example, 25 over 36 is already simplified. So let's apply the quotient rule on the radical and write it as square root of 25 over square root of 36. And now taking the square root of 25, this gives us 5, and the square root of 36 is 6. So this radical simplifies to 5 over 6. For the next example, again the fraction 3 over 64 is already simplified, so let's apply the quotient rule on the radical and write this as square root of 3 over square root of 64. So the square root of 3 is already simplified, so we just rewrite it, and we can take the square root of 64, which is 8, so this radical simplifies to square root of 3 over 8. And for this example, we can use our quotient rule and write this as square root of 40 over square root of 81. So we can simplify the square root of 40 since 40 has a perfect square factor of 4. So we can rewrite this as the square root of 4 times 10. And then the square root of 81 is 9. So using the product rule, we have square root of 4 times square root of 10. And this simplifies to 2 times square root of 10 over 9. So now let's go over how to simplify radicals containing variables. So we know that the square root of 25 is 5, since 5 squared equals 25. The same idea works with variables. So the square root of x squared is x, since x squared equals x squared. And the square root of x to the 6th power equals x to the 3rd, since x to the 3rd squared equals x to the 6th. And the square root of x to the 14 equals x to the 7th, since x to the 7th squared equals x to the 14. Or we can also use the relationship between rational exponents and radicals and rewrite the square root of x squared as x raised to the 2 over 2. And simplifying the rational exponent, we get x to the first power, or simply x. And for the next one, we can rewrite this radical as x to the 6 over 2, and this simplifies to x to the third. And the same thing for the last radical, we can rewrite it as x to the 14 over 2, simplify the rational exponent, and we get x to the 7th. Since we can rewrite square roots as an expression with a rational exponent with a denominator of 2, then any variable inside the square root can be simplified if it is raised to an exponent that is divisible by 2. And in case we have a square root of a variable with an odd exponent, which won't be divisible by 2, then we can rewrite it as factors so that one of the factors has an even exponent. For example, consider the square root of x to the third power. We can rewrite this radicand as x squared times x so that one of its factors has an even exponent. And then using the product rule, we can rewrite this as the square root of x squared times square root of x, simplify the first radical, and we get x times square root of x. Or if we have the square root of x to the 7th, we can rewrite the radicand as x to the 6th times x so that one of its factors has an even exponent. So this becomes the square root of x to the 6th times x, and using the product rule, we can write this as the square root of x to the 6th times the square root of x, and this simplifies to x to the third times square root of x. Okay, let's try a few examples. To simplify the square root of 16x to the 5th, notice how 16 is already a perfect square. However, x to the 5th is not, so we can rewrite this as x to the 4th times x to the 1st, so that one of its factors has an even exponent. So this becomes the square root of 16 times x to the 4th times x, and then use our product rule and simplify square root of 16, which is 4, square root of x to the 4th, which is x squared, and square root of x is already simplified, so we just rewrite it, and this radical simplifies to 4x squared times square root x. For the next example, we can rewrite 8 so that one of its factors is a perfect square, so 4 times 2. X cubed we can rewrite as x squared times x, and y squared is already a perfect square, so we can just leave it this way. So we rewrite the radical as the square root of 4 times 2 times x squared times x times y squared. And then we use our product rule and simplify. So the square root of 4 is 2, and the square root of 2 is already simplified. Square root of x squared is just x, and the square root of x is already simplified, and then the square root of y squared is y. And now we can rewrite this so that our non-radicals are at the front, and then using our product rule, we can rewrite square root of 2 times square root of x as the square root of 2x. So our radical simplifies to 2xy times the square root of 2x. And for the next example, we can use our quotient rule and write this as square root of 45x to the 27th over the square root of y to the 8th. So we can rewrite 45 as 9 times 5 so that we have a perfect square factor. And we can rewrite x to the 27 as x to the 26 times x so that one of its factors is a perfect square. And y to the 8th already is written with an exponent that is divisible by 2. So we can rewrite the numerator as square root of 9 times 5 times x to the 26 times x, and the square root of y to the 8th simplifies to y to the 4th. And then we use our product rule on the numerator and simplify. So the square root of 9 is 3, square root of 5 is already simplified, the square root of x to the 26 is x to the 13, and the square root of x is already simplified. And then rewrite this so that our non-radicals are written first, and use the product rule on the radicals to write them as 1. So this simplifies to 3x to the 13 times square root of 5x over y to the 4th. So sometimes it's useful to first apply the product or quotient rule of square roots, and then simplifying. So for this example, we can't simplify the square root of 6x or the square root of 3x, but we can use the product rule to combine them, and this becomes the square root of 6x times 3x, which simplifies to the square root of 18x squared. And then now we have a radicand that can be simplified. We can rewrite 18 as 9 times 2, and x squared already has an even exponent, so we can leave it the way it is. So this becomes the square root of 9 times 2 times x squared. And then use our product rule and then simplify. So the square root of 9 is 3. The square root of 2 is already simplified. And then the square root of x squared is x. And then rewrite this so that our non-radicals are written first. So our expression simplifies to 3x times square root of 2. For this example, you could first simplify the numerator, but it will be faster if we apply our quotient rule to this and write this as the square root of 20x to the 5th over 5x, and then simplify the radicand. This simplifies to 4x to the 4th. And then using our product rule, we have square root of 4 times the square root of x to the 4th, and this simplifies to 2x squared.